Hello viewers, in this session I would like to discuss on plastic analysis of continuous beam provided uniformly distributed load on the span AB and two concentrated loads on the span BC. And this is what the continuous beam is. So now in this I would like to start analyze for first span, that is span AB. So for the span AB, the mechanism will be like the mechanism is expected to have in this direction. So this is theta 1, this is theta 2, and this would be the deflection which is expected to have, right? And the plastic moment is expected to see in this direction, either in the both support A and B. So this we do not expect to have the exact deflection, the total deflection exactly at the center of the total span, since both the supports are simply supported. In that case I do take this as distance x, and this will be 4 minus x, right? So at the distance x from the support A, it is expected to have maximum deflection under this 5 kilonewton load. Okay, so now this is theta. So if you consider here, this is 1.5 mp theta, which is given in this question. Okay, so now it is theta 2, this is theta 1 on the opposite sides. It is 2 mp theta 1 plus theta 2, and it is 1.5 mp theta 2. Here we do not get any movement because it is simply supported. So now if I start writing for internal work done, it can be written as, this is 2 mp theta 1 plus theta 2, this is plus 1.5 mp theta 2. So now the relation between theta 1 and theta 2 can be obtained like what I can take this delta equal to x theta 1 or 4 minus x theta 2 can be written. This 4 minus x theta 2 or x theta 1 can be written. So theta 1 is 4 minus x theta 2 by x, or theta 2 can be written as x by 4 minus x theta 1, right? So either of these two can be taken here in this internal work done. So now what I do, I will take this theta 2 as in terms of theta 1, I do substitute here. So if I rewrite the internal work done, 2 mp theta 1, right, plus 2 mp theta 2 plus 1.5 mp theta 2. Okay, so now this 2 mp theta 1 is as it is. So I got 2 times of theta 2, so 3.5 times mp. So this theta 2 can be written as x by 4 minus x times theta 1, right? In this way we can write. So in these two I can take this mp theta 1 as a common, and if I write this, it is 2 plus 3.5 x divided by 4 minus x, right? 3.5 x divided by 4 minus x, this is 2 plus. Okay, so now I just need to simplify this equation. So what I do, this is internal work done. right? So this is internal work done. I keep this mp theta 1 as it is, and this whole term, and I do write this external work done now. External work done. So external work done is area under the load. So area is half base into height. Half base is 4 meter, and height is delta. The height is delta. The delta can be written as x theta 1 or 4 minus x theta 1. So here I take x theta 1. So the load is 5, right, under this delta. So whatever we have written, this is the area, half base into height. Height is this one, under the load, the deflection under the load. So this is the total load and this is the deflection. So if I write this is 2x theta 1 times 5. So it will be 10x theta 1. Yes, so this is the delta, means the total area under the load, right? So 10x theta 1 is the external work done. So this is not the correct. So this is x theta 1. The external load is external work done is x theta 1. Now I would like to equate these two equations, that is internal work done equal to external work done, or external work done equal to internal work done. So what I do here, so first I will take this external work done, 10x theta 1, which is equal to internal work done, that is mp theta 1 plus 2 times 3.5 ux by 4 minus x, right? So this theta 1 will get cancelled. So before that I will simplify this one. This is mp plus this 4 into 2 is 8, and minus x into 2 is minus 2x, plus 3.5 x divided by 4 minus x. So if I simplify this one, so now what I can write, this mp, this is 8 minus 2x plus 2x 1.5 is minus 2x plus 3.5 is 1.5x, and 4 minus x on the denominator, and here it is 10x. So theta 1 and theta 1 got cancelled here. So here it is multiplication, because I have taken common, and 2 plus 3.5 is here. mp theta 1 is a common, so it will be multiply here. It is multiplication. Okay, so now this is equation. Now I need to write this as mp. So I need this mp. So if I want to write this in terms of mp, it must be multiplied to 10x. So 10 into 4 is 40x minus 10x into x is minus 10x square divided by 8 plus 1.5x. So I have multiplied this bracket to 10x. So 4 into 10 is 10x, and minus x into 10x is minus 10x square, and this divided by this 8 plus 1.5x will come to denominator, and this is mp. So now we need to know what is mp. So to get that mp, we must know the value of x, so which is this one. So where we are getting this maximum deflection. To obtain that, so now for the reference, I will write here mp again. This is mp. We got 40x minus 10x square divided by 8 plus 1.5x. To get this, we have an equation. that is dmp by dx, which is equal to 0. So to get this maximum and minimum values of x, we have this mathematical simplification, f of x times f of x, which is equal to n of x by d of x. So denominator and numerators. This numerator is nothing but n of x is nothing but 40x minus 10x square, and denominator is 8 plus 1.5x. Okay, so now if I want to write this f dash of x, so it will be n dash time denominator d dash of x, means differentiating the term. So if I write n dash of x, so if I differentiate this with respect to x, it is 40 minus x square is 2x, 20x, and d dash of x, if I differentiate, so it is 0, it is 1, so it is 1.5. So it is 1.5 only. So now f dash of x, if I want to write in the simplified form, we have this equation times d of x minus n of x times d dash of x. This is n dash and this is d dash, whole divided by d of x whole square. So this is the equation. We must remember to substitute this and to get the value of x. So now if I substitute this, what I do get here, n dash of x is 40 minus 20x, and d of x is 8 plus 1.5x. Again, n of x is 40x minus 10x square times 1.5, right? So now just thing is to multiply the brackets and simplify it. So if I multiply this bracket, and however in the denominator I will be having this one, this is d of x whole square, that is 8 plus 1.5x whole square. So now if I simplify this equation, what I do get, so I can get here as 320, that is 40 into 8, 320 plus 60x minus 160x minus 30x square and minus 60x plus 15x square. And this 40 is multiplied to these two terms, and this minus 20 is multiplied to these two terms, and this 1.5 is multiplied to this one and this one, and this is the total nominator values, and at the denominator it is 8 plus 1.5x whole square. So this 60x plus 60x and minus 60x will get cancelled. It is 320 minus 160x, this is minus 30 and plus 15, it is minus 15x square, right? So which is 8 plus 1.5x whole square. So now this f dash of x, here dmp by dx equal to 0 equal to f dash of x, it is the actual equation is. So this term f dash of x equating to 0, so it will be 320 minus 160x minus 15x square. So if it is multiplied with 0, then this term will be 0. So now I need to write this in terms of x square, x, and digit numbers. So if I do that, I would like to take this 15 common, so that it is x square minus x square. It is now all the signs will become opposite. So if I take this x as positive now, and my plus 160 by 15x minus 320 by 15. So this is x square plus 10.66x minus 21.33. So this is the 2-degree equation. Either you can use Sridhar's equation or you can use the calculator to get the equation values. So if I solve for this, so x is equal to 1.722 meter, which is the many positive value, and other negative value is not considered because we have got the span is only a 4 meter. So now this is the MP. In this MP I got the value of x as 1.7722. I should substitute this x here in this equation to get MPs. So MP for the span AB is 40 times 1.722 minus 10 times 1.722 square divided by 8 plus 1.5 times 1.722. So if I do this, the value of MP is 3.706 kilonewton meter. So this is the plastic movement for span AB when the UDL load is given and this UDL load is provided for simply supported beam. If in the case here we got a fixed end, then the maximum deflection of the span AB is expected to have at the center when this support is fixed. When either of the supports are simply supported, then we cannot imagine or get the deflection exactly at the center. In that case, the maximum deflection is eccentric. So that is why we have taken this x and 4 minus x. So in this, the value of x is 1.722, and if I substitute that, we will be getting the plastic movement of the span AB is 3.706 kilonewton meters. Here for second span BC, it is considered for 15 kilonewton load. The mechanism on the span BC, it is considered for 15 kilonewton load. If I draw that mechanism, or case 2 we can say, so here we will be getting 1.5 MP plastic movement, and here it is 1.5 MP plastic movement for 2 rotations, theta 1 and theta 2, and at the support C it is 0 since it is simply supported. So we can take this as case 2 or mechanism 2. So now if I draw this similarly for case 3, so it will be delta 1 and this is delta 2 and this is theta 2 and this is theta 1 meter, and this is 3 meter 1 meter, and here we can get 1.5 MP theta 1, 1.5 MP theta 1 plus theta 2. Here it is 0. Again it is simply supported beam. This is for case 3 or mechanism 3. Right. So now what we need to do here, we need to refer the similar procedure. You can refer my previous video which I have done the plastic analysis of continuous beam for the 2 concentrated loads, and mechanism 1 and mechanism 2 can be written in this form by referring to the provided numeric, and the procedure can be followed by referring to the previous video, right? So, and some of the plastic analysis concepts have got some limitations. You can refer the description for the limitations. Thank you.